So, Bismillahirrahmanirrahim. So now I am going to present about our group's block diagram. So this block diagram is using microprocessor, is showing that our system using microprocessor Nucleo L432KC, a sensor and a 7-segment display followed by 2 LEDs, which are green and red LEDs. So now to begin with, input part, which is the sensor. The sensor will send data to Nucleo L432KC. And it operates with a frequency of 1 MHz. So this will send data to the microprocessor, which is the brain of the system, which is the Nucleo L432KC. So this microprocessor will control the output, which are the 7-segment display and green and red LED. So next part for the output explanation involving 7-segment display, green LED and red LED. So for the 7-segment display, will show 8-segment display of numeric information such as sensor reading or status value. So next one, the red LED, that the red and green LED that shows the specific condition or operating condition of the system. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Sharif, and now I will continue to explain schematic diagram. So for our project, we need to use Nucleo L432KC, but since it was not available in the simulation software that we use, which is Prius, we use microcontroller STM32F401CC. Despite this difference, both these two microcontrollers have the same fundamental working principle. So this is our circuit, and we have 7-segment display, resistor, LED red and LED green, and also push button. So push button will be the input, and we connect it to PB3, the one and only input. And LED green, we connect it to PB6, which is the output, and also the output is LED red, we connect it to port B5. And also 7-segment display, we connect it to port A0 and port A6. The main function of the resistor is limiting the current, because we want to avoid our component from burnout. And that's all from me. Thank you.
So hello, my name is Muhammad Amirul Aiman, and I will tell about my hardware setup group. So here is we use STM32L432, and then we have a bunch of wire, and we have a resistor which for our 7-segment, and our red LED and green LED, and then our button which we use pull up with a resistor. So this is like a common setup for the 7-segment LED, but here I want to tell you about the PA7, which is for our C for the 7-segment. Why do I put the C not in the, because we use a GPIOA, I use A7 because at the STM, the port for the A2 or A3 I think is at A7. So our C here, there's the brown wire, put at the number 3, which is 0, 1, 2. So our 2 is at the A7, yeah, and then the others is same. So that's all from me. Thank you.
My name is Adi bin Shonizal. I'm going to present flowchart for this project. So firstly, flowchart for the general, we have a LED green, LED red will turn on and LED green will turn off. Then it will meet the condition where the pedestrian is detected for greater than equal to 200 milliseconds. If it's not, then it will have the same condition as before. And if it's yes, the timer will trigger counter by 10. Then it will go to the 7-segment display as a counter. Then the counter will have a decrement by 1. After that, the LED red will turn off and LED green will turn on. And after the LED has been meet their condition, they will meet another condition where the counter is equal to 0. If it's yes, then the timer is end. If it's not, then they will go back to the 7-segment display counter. Next, I will show you the flowchart of the main function. So basically for this flowchart, it initializes the system and the loops of the system. Next, for the flowchart of the interrupt handler, so this flowchart function as to detect the button press and the calls for the button handler. So this is the flowchart of the button press handler. So for this, it applies the debounce time for 200 millisecond, and it also start the countdown for this flowchart. Next, there is flowchart of countdown. So for this flowchart, it controls the LEDs that is red and green, and it also updates the display on the 7-segment display, and also you have loops until 0. So for this also, it has reset function where it resets LEDs and clears the display after the green countdown over here. And last but not least, we have the flowchart of display. So for this flowchart, it controls the 7-segment display output. So when the sensor detected the pedestrian, then it has the timer will have a 10-second countdown. Then when it turns 0, the green light will turn on.
My name is Muhammad Syarul Naim bin Masni. So for the coding, we need to define the port and pins first. So we need to connect the button, LED, and the 7-segment display to the ports. And then we make a coding for countdown from 9 until 0. And for the coding, we need to put interrupt function so that when we press a button, it will start count for red LED. It will count down from 9 until 0 until it will turn off and then turn to green LED, and green LED will on and red LED will off, and the countdown will start from 9 until 0. And after it reach 0, it will start loop, and the red LED will on and the green LED will off. So for the 7-segment display, we need to set the pin first. So we set to the common ended. That is when it become low, the LED will turn on. So after that, we reset all of the system and initialize it. Then we need to put the frequency for the clock and run the code.
For hardware verification, as we can see, the red LED will turn on by default. Then when the sensor is triggered, that is the pedestrian, the timer will count down from 4, 3, 2, 1, and the green light will turn on for 10 seconds for pedestrian walk. After the countdowns ends, the timer and the green LED will turn off and the red LED will turn on. So for this, I will show you back the hardware verification simulation. So the countdown will have 10 seconds. So the green LED will turn on. After the LED turn on, they have 10 seconds and the red LED will turn on back. So that's all from us. Thank you.